Hi everyone, in this session we are going to talk about the gaseous state, namely how we can understand the question from the point of view of the system. Often when we are given a question, alright, we straight away jump into a question and take the values and throw it into the ideal gas equation, and sometimes you realize that it does not give you the correct answer. So in this video I'm going to share with you what you can usually do to understand the question better, alright, in which I call this understanding the system. So if you look at different questions, alright, you will realize that they always use the same kind of objects. They can use things like a balloon, they can use a syringe, they can use containers that are connected together, alright, or they can just use a simple container where they allow gases to be pumped in. Alright, so in the first case, alright, of the syringe, okay, here, case number 1, right, there are a couple of things that you need to take note of. So the first thing is how the syringe actually works. There are two ways that you can do that. One is you can hold the syringe, pull the piston out, and just hold it there using your hands. Alright. If not, the other way is for it to move freely on its own. Okay, so what you will do is in both cases you are actually looking at different things. So in the first case where you are pulling out the piston, alright, let's say the initial volume was 10 cm cube and you pulled it to 20 cm cube and you held it there, alright, this allows you to change the volume of the system. So this change in volume is going to lead to a change in pressure of the system. If we just look at the equation PV is equal to nRT, this is a constant. So if volume goes up, pressure should go down. Alright, so this is the first case that we can look at. Alright, other than that, there is another way that we can look at syringe questions. That is when we pull the syringe out and we release it. Okay, notice there's a stopper here. Alright, so what is going to happen is that the pressure within the syringe is going to drop, like what we have seen in our equation. When V goes up, P goes down. So when we allow the syringe, or rather the piston, to move freely, we are actually comparing the internal pressure, right, the gases acting on top on this piston, versus the external pressure, which is your atmospheric pressure. So at the end of the day, if it's allowed to equilibrate, okay, what you will notice is that pressure, the internal pressure of this syringe will eventually match the external pressure, which is the atmospheric pressure, which is 1 atm. So when you tackle questions and they say we release the syringe and let the syringe move by itself, we are ultimately looking at reaching a pressure of 1 atmosphere. Okay, so for the other example, what we can see is that we have this balloon here, which is number 2. So how it is very similar to our discussion about the syringe. So we have the gas particles pushing on the balloon, and we have the external pressure, which is 1 atmosphere, pushing back to the balloon. So no matter what happens, it is the internal pressure will want to match the external pressure. Alright, so what is going to happen is that if we pull out our equation of PV is equal to nRT again, P at the end of the day will be 1 atmosphere. Alright, and what usually happens in this case is if I were to keep the amount of gas constant and I change temperature, let's say I increase temperature, volume would go up, because this is a constant, this is also a constant, and of course since I kept the amount constant, this will also be a constant. Alright, but in another situation, if I were to keep the temperature constant, ideal gas constant is a constant, P is a constant, so if I increase the amount of gas, alright, by pumping in more gas into this system, the volume of the balloon should increase, and in this case similarly you should obtain 1 atmosphere. Alright, let's move on to our third case here. Alright, in our third case you have 2 different containers. There are 2 different types of questions that you will often see. One of it is where you have 2 gases which mix together. So what you can do is to calculate the partial pressure of each individual gases, either A, for A and B, and then you add them together to find out what is the total pressure of the system. Alright, because let's say I have 1 mole of A at the start and I have 2 moles of B at the start. This is a 10 cm cube container, this is a 30 cm cube container. Alright, if we look at the partial pressure of A, PV is equal to number of moles of A times RT, we take PBV, so NB times RT, okay, we will be able to calculate the partial pressures of A and B, and to find the total pressure, we just have to add them together. Of course, there are many other ways to do that, but all you need to know is that when you open up the valve, both gases will occupy a greater volume. Okay, you can try out some numbers and you'll realize something very interesting about this case. So I will not elaborate any further. You can try it on your own. Alright, but there's also another case where we look at gas A, and in gas B they will call this an evacuated chamber, or rather this is vacuum. Alright, so what happens when you open up the tap is that the amount of gas, which is the amount of A, stays the same. Alright, so PV is equal to nRT. The amount stays the same. The temperature stays the same because no one changed the temperature. The ideal gas constant is a constant. So what happened here was that the volume has increased. So we would expect the pressure of the system to decrease. Alright, so that is when the other chamber is a vacuum chamber. So for the last case here, alright, a typical container PV is equal to nRT. People call you'll usually see cylinder, container, things like that, or container with a fixed volume. Alright, basically they are trying to tell you that the container size or the cylinder's volume is fixed. Alright, so if it's fixed, this will be a constant, my R will always be a constant. So the only two variables that you can change is to change the amount or the temperature. So this is all there is for this situation. Alright, so I hope that in this short video you can actually see these 4 different cases and how they actually affect which value is constant. Alright, so by understanding the system, you will be able to understand how you can eventually tackle the question more effectively. So it's very, very important for you to know what is going on and not just take numbers and throwing it into various equations.